The notes for Unit 3, Lesson 6 will cover double replacement reactions. So with double replacement reactions, as you can probably determine, two elements are switching places with one another. And when this happens, the product that you see, the indication of the chemical reaction that occurs is usually a precipitate. So a precipitate or a color change are the two indications that you would actually see. These are two indications that we talked about briefly at the beginning of this unit. So precipitate, remember, is when you take two aqueous solutions, when you mix them together and they turn chunky and form a solid. So that's a precipitate. So in double replacement reactions, we have to use the solubility rules to figure out which product is actually forming the precipitate. So make sure you have your notes packets ready to go, and you'll also want your yellow periodic table packet. All right, so double replacement reactions are when two elements replace two other elements. So in the picture example, you would have AB plus CD produces AD plus CV. So as you can tell, two of the elements in that reaction are going to switch places with one another. So in the example below, when you look at a reaction, if you have two ionic compounds, so an ionic compound is a positive with a negative, if you have two of those reacting together, then you're going to have a double replacement reaction. So I always say, like, if you have two double compounds, but a compound is going to consist of a positive and a negative ion reacting with another positive and another negative ion. So when you look, those are things to look for. So to figure out what products will be made, you have to look at the individual charges. So if we know Ki is reacting with PbNO3, 2, the charge of K is +1, I is -1. If we look at lead nitrate, so lead can have more than one charge. So we have to look at nitrate. Nitrate is -1. We have two of them, so lead has to be +2. So when you're predicting your products, the positive ion from the first reactant has to combine with the negative ion from the second reactant. So potassium, which is positive, has to combine with the negative. And so when you reform the elements into new products, you always have to have a positive with a negative charge. So here's our KNO3. And again, when you form new charges, you have to go back to the individual charges. So potassium is +1, Potassium is +1, and nitrate is -1, so that's why the formula is KNO3. And then the other product, lead, is going to combine with iodine because lead is positive and iodine is negative. So when you form a new product, again, you have to look at the individual charges. So lead is +2, I is -1, so we would need 2 iodines. So once you're done balancing the charges, that's when you would go back and add the coefficients. So in a double replacement reaction, you have two elements that are switching places with one another, but when they switch, you have to have a positive combined with the negative. All right, so another thing to notice is we have the AQ and the S and the AQ. So aqueous means that something is dissolved into solution. So Ki and PbNO3 would both look like a solution, like the potassium iodide is dissolved, the lead nitrate is dissolved. So this would almost appear that two liquids are being mixed together. When that happens, you get this solid and another aqueous solution. So this is actually happening in the reaction, but since it's aqueous, it's not anything that you see. So the lead iodine is the example that you would actually see because it's the solid. So here's how you figure out which one of those products is the solid and which one would be aqueous. You have to use the solubility rules. So when you have your products and you figure out what your products are, you're going to use the solubility rules to figure out which one is the precipitate. The precipitate is going to be the solid. Okay, so most of the rules, like nitrates, chlorates, acetates, most of them are going to focus on the negative ion. Sulfates, hydroxides, so all of these are negative ions. So usually you can look at the negative ion and use that to figure out which solubility rule you are going to use. The one that doesn't focus on the negative ion is rule number 2. So rule number 2 is saying most salts containing the alkali metals. So alkali metals are in group 1 of the periodic table. Lithium, sodium, potassium, cesium, rubidium, and ammonium. Those are all soluble. So soluble means that the substance will dissolve. So soluble, whoops, that should be an equal sign. Soluble means that it is aqueous. Insoluble means that the substance will not dissolve, which means that it's going to form a solid, which means that that will be your precipitate. So the solid is actually the one that is insoluble. So again, chemistry is opposite world. All right, so if we look at these products, we have lead iodide. So iodide is our negative ion. So I'm going to erase all my little notes here and find iodide. All right, so iodide is mentioned in rule number 3. So most chloride, bromide, and iodide salts are soluble, which means they will dissolve. Exceptions are salts that contain the following. So here we have lead combined with iodide. So that is an exception to the rule, which means that that is our solid precipitate. All right, then if we look at the next one, we are going to look at KNO3. So NO3 is our negative ion. Let's switch colors here. Nitrates are mentioned up here in rule number 1. Most nitrates are soluble. So this, because it has a nitrate, is going to be aqueous. This KNO3 actually applies to rule number 1 and rule number 2 because it has a group 1 metal as well. So as long as one of the rules applies, that's what it goes with. So like KNO3 happens to have potassium and nitrate, but even if it just had potassium or just had nitrate, it would be soluble. So remember, soluble means it's aqueous, which means it dissolves and you don't see anything in the reaction. So PbI2 is actually the precipitate that you would see in the reaction that would cause the color change. All right, so here are some examples. I'll talk through the first one and then I'll have you guys try the next two. So first you have to predict the products. So in order to predict the products, you have to look at the charges. So lithium is +1, sulfide is -2, silver is +1, and nitrate is -1. So when these elements switch places, remember the positive ion is going to, all right, the positive ion from the first one is going to combine with the negative ion of the second one, and then the other positive ion will combine with the other negative ion. So lithium is going to combine with nitrate, and when you form a new compound, you have to go back to the original charges. So lithium is +1, nitrate is -1, so your formula is just LiNO3. And then the second one, silver, which is positive, is going to combine with sulfur, which is negative. Silver is +1, sulfide is -2, so this one will be Ag2S. And so once you have those charges balanced, then you can balance the number of atoms on each side of the arrow with your coefficients. So on the reactant side, we have 2 lithiums, so we need 2 lithiums on the product side. We have 1 sulfur and 1 sulfur on the reactants and product side. On the reactant side, we have 1 silver, and on the product side, we have 2 silvers. So we'd have to put a 2 here. And that gives us 2 nitrogens. Here we have 2 nitrogens. And then we have 6 oxygens here, and we have 6 oxygens here. So this would be our balanced equation. All right, so the next one, we'll have you guys pause the video, try this on your own, see how it goes, and then you can unpause the video to check your answers. But like I said, make sure that you try and make mistakes first on your own before you check the key. All right, so hopefully you've tried this one out. When you first are figuring out the products, you have to look at the individual charges. So these just come from the periodic table of ions. So barium, which is positive, is going to switch and combine with the negative ion of carbonate, and then sodium is going to combine with chloride because sodium is positive and chloride is negative. So the first compound will be barium and carbonate. So if the product or the reactant has a polyatomic ion, remember a polyatomic ion has to stay together. So that's the only subscript that would ever transfer over from one side to another. Since CO3 is a polyatomic ion, it has to stay together because it acts like one thing. So barium is +2, carbonate is -2, so it would just be BaCO3. And then our second product is going to be sodium, which is positive, combining with chloride, which is negative. And so sodium is +1, chloride is -1, so it's just NaCl. So that's kind of what I was referring to with the polyatomic. Like here, this 2 from sodium is only there to balance the charges, whereas this 3 is part of carbonate. So that 3 has to stay with the carbon and the oxygen, but this 2 from sodium doesn't necessarily transfer because it's only based on the charge of each ion. So that is also something tricky to pay attention to. All right, so now I'm going to erase all my extra stuff here. Now we can finally go back and balance the number of atoms on each side. So on the reactant side, we have 1 barium on the product side. We have 2 chlorides on the reactant side and only 1 on the product side, so we need a 2 here. That gives us 2 sodiums. Here we have 2 sodiums. Here we have 1 carbon, 3 oxygens, 3 oxygens. So this would be our final balanced equation. So once you have your balanced equation, then we have to figure out which of these products actually formed a precipitate. So we're going to look mostly at the negative ions. So the first one has a carbonate. So in your rules down here, the solubility rules, you are going to find carbonates, which is down here on rule number 6. So rule number 6 says sulfides, carbonates, chromates, and phosphates are insoluble except if they have a group 1 metal. So if they have any of these, then they would be soluble, but otherwise they're going to be insoluble. Insoluble means that that is your precipitate, which is your solid, which is labeled with an S. So I'm going to put an S after it because that is insoluble. All right, the NaCl is going to, let me erase these other ones quick. NaCl has a group 1 metal. Oops. So it does have this sodium here. So because it has a group 1 metal, we know it's already soluble. So if it's soluble, that means that everything is going to dissolve and it's going to be aqueous. All right, so here is our last and final example. Again, make sure you try this on your own before you check the key. So the first one, we have lead nitrate. Nitrate is -1. We have 2 nitrates, so lead has to be +2. Sodium is +1 and sulfate is -2. So in this one, we actually have 2 polyatomic ions that we need to make sure that they stay together. So when these 2 elements switch places, lead, which is positive, is going to combine with the negative from the second reactant, and sodium is going to combine with the negative ion from the first reactant. When you write your products, the positive ion, always comes first. However, it doesn't matter which order you write the products. So I'll show you what I mean by that. So lead, which is +2, is going to combine with sulfate, which is -2. So since it's +2, -2, we don't need any other subscripts. But remember, SO4, because it's a polyatomic ion, has to stay SO4. All right, and then our second product is going to be sodium is going to combine with the nitrate. Sodium is +1, nitrate is -1. So again, we don't need any extra subscripts other than the NO3 from the nitrate. All right, so what I meant by my previous comment, you could write PbSO4 plus NaNO3, or you could write NaNO3 first and PbSO4 second. So it doesn't matter what order these go in, but what it does matter is that the sodium is combined with the nitrate. So either way is fine. All right, let me erase some of my markings so we can balance our equation now. All right, so when you're balancing the number of atoms on each side of the arrow, so we have 1 lead on the reactant side, 1 lead on the product side. Here we have 2 nitrogens on the reactant side, and here we only have 1, so we have to add a 2 here. This 2 means we have 2 sodiums, which balances out the 2 sodiums on the reactant side. Here we have 2 nitrogens on the product side, and here we have 2 nitrogens on the reactant side. And then on the product side, we would have 6 oxygens in the, let me erase these. All right, we would have 6 oxygens in NO3, but then we have 4 more here, so that would give us a total of 10. Here we have 6 oxygens plus 4 more, which would give us a total of 10. All right, so that should be all we need to balance the equation. All right, so now we can use the solubility rules to figure out which of these products is soluble and which one is insoluble. All right, so the first one, we have a sulfate. So then we find sulfate down in the solubility rules. Here, rule number 4 talks about sulfates. So most sulfates are soluble, which means they're aqueous, except ones that have BaSO4, PbSO4, which is what this one has. So if that's an exception to the rule, that means that this is going to be solid because that is going to form our precipitate. All right, so then if we look at our second example, NaNO3. Na has a group 1 metal, which is listed in rule number 2. So we know because it contains Na that this is going to be soluble, which means it dissolves and is aqueous, and you're not going to see anything different in that reaction. So remember, soluble means everything's dissolved, which means it would be labeled with an AQ. And then insoluble means that it doesn't dissolve, which means it's going to form a solid, which that is your precipitate. All right, hopefully that helped with examples. As always, let me know what questions you have.